For what we have in the case of number 94, okay, we have a trinomial expression, and the greatest common factor is only going to be at 1. So you don't have m or n common to all three expressions. Now this particular trinomial we can factor, and one approach again is using factoring by grouping. Okay, so we have for the first and last coefficients. Okay, so again we have 9 times 49 is equal to 441. And in looking at factors of 441, that will add up to 42. And it's like the number 1600. Okay, 441 is a perfect square. Now the square root of 441, okay, that's going to be at 21. So you got 21 and 21, and so we can take these values and split up, okay, what we have for the middle term. Okay, and so just taking and rewriting. So we have 9m to the fourth plus 21m to the second into the fourth. Again, 21m squared into the fourth. And we have plus 49 into the eighth. Okay, now entering the stage of where we are grouping. So we have 9m to the fourth plus 21m squared into the fourth. The middle operation we have is going to be addition. So we have plus the quantity. So we have 21m to the second into the fourth plus 49 into the eighth. And to looking at drawing out, okay, the greatest common factors. So we have for the first two terms, okay, the greatest common factor is going to be at 3m squared. And taking into 9m to the fourth, so you have 3m squared into 21m squared into the fourth, so you have plus 7 into the fourth. Bringing down the addition. Okay, greatest common factor between these last two terms is going to be at 7 into the fourth. And taking into 21m squared into the fourth, so I have 3m squared, taking 7 into the fourth into 49 into the eighth, I have 7 into the fourth. If you notice, we had the same binomials. So we have 3m squared plus 7 into the fourth. And quantifying the outside terms, turns out we have another 3m squared plus 7 into the fourth. So we have a repeating binomial, and so we have for the final answer in this one, we end up with 3m squared plus 7 into the fourth quantity squared. Now, in the case of what we have with regard to working with cubes, and now once again, we have working with sums of cubes. And we have with the algorithm. Okay, so again, we have a to the third plus b cubed is equal to the quantity of a plus b times that of a squared minus ab plus b squared. Now for what we have in the case of number 102, So we're looking at a sum of cubes, whereupon we have u to the third plus 343. And just for what we have in context, okay, so to give you just a better bird's eye view, what we have here. Okay, so we have for u to the third. Okay, so we have the cube of u. 343 is going to be a perfect cube. So you think of a represented by u, b by 7. So in factoring, okay, so we have u plus 7. I have times quantity, so we have u to the second minus, okay, and we have u times 7. And we have for b squared, okay, so we have 7 to the second. And we have for the final answer in this particular case, so I had the quantity of u plus 7 times that of u squared minus 7u plus 49. And what we have with regard to number 106, and here we have working with the difference of cubes. And for what we have here, so we have a to the third minus b to the third, and we have with the factorization, so we have the quantity of a minus b times that of a squared plus ab plus b squared. And for what we have in number 106, and in this setup, okay, so we have 27 m to the 12th minus 64 n to the 9th. So here we have perfect cubes. Okay, for 27 m to the 12th. Okay, that's going to be the perfect cube of 3m to the 4th. And for 64 n to the 9th, okay, that's going to be the perfect cube of 4n to the 3rd. So you can envision, okay, a is going to be represented by 3m to the 4th, b by 4n to the 3rd. So for a minus b, we're going to have 3m to the 4th minus 4n cubed. And as for what we have for a squared, okay, so we'll be looking at the square of 3m to the 4th. And then we have plus a times b. Okay. So I have plus 3m to the 4th times 4n to the 3rd. And I have plus the square of 4n cubed. And so we have, upon looking at the factorization, okay, so I have 3m to the 4th minus 4n cubed. And for 3m to the 4th squared, 3 squared is 9, m to the 4th squared is going to be m to the 8th. And we have plus 3 times 4 is 12. Then we have m to the 4th, n to the 3rd. And for the square of 4n cubed, 4 squared is 16, n cubed squared. Again, by the power property of exponents, okay, we have n to the 6th. So we have with the factorization, we have the binomial with 3m to the 4th minus 4n cubed. And with the trinomial, we have 9m to the 8th plus 12m to the 4th n cubed plus 16n to the 6th. And now, and what we have with regard to number 108, and in this one, okay, so we have a 4-term expression. Now for what we have regarding 108, okay, so I have 4y to the 4th minus 10y cubed minus 36y squared plus 90y. And this problem will have a little different twist to it. Now, we've got 4 terms as opposed to 3. And now we have even coefficients, and all the terms are in the variable y. And if I factor out, okay, the greatest common factor, so we have it 2y. Now we have 2y cubed minus 5y squared minus 18y plus 45. And so in looking at what we have, okay, with regard to the factorization here, and this will have a little different twist to it, but now this is one where we can once again factor by grouping. So just taking what we have with this 4-term expression. Now we had the coefficients are proportional, where we can perform factoring by grouping. So in terms of taking what we have here, okay, so we've got 4 terms, and if I group together first 2 terms, so I have the quantity of 2y cubed minus 5y squared, and if you notice we have for the operation that is in the middle, okay, so you have subtraction, so I have subtracting the quantity, okay, so negative 18y is going to be the opposite sign of 18y, 45 is going to be the opposite sign of negative 45, and drawing out, okay, the greatest common factors. So for 2y cubed minus 5y squared, okay, greatest common factor is going to be at y to the second. And taking into 2y cubed minus 5y squared, so I have 2y minus 5. And taking, once again, the subtraction and drawing out the greatest common factor that exists between 18y and minus 45. So we have 9, and 9 into 18y minus 45. Okay, that is also going to be at 2y minus 5. And we have with the common binomial, okay, so we have 2y minus 5, and we have times the quantity of y squared minus 9. And it turns out that for this second factor, okay, we have a difference of squares. And so in the case of the complete factorization of this 4-term expression that was factored out, we have 2y minus 5. And for y squared minus 9, we have the quantity of y plus 3 times that of y minus 3. Okay. So taking what we have in the details. And so we're going to have for this problem, again, we had already factored out 2y. And so we have for the complete answer in this one, so we have 2y times the quantity of 2y minus 5 times the quantity of y plus 3. And then we have times that of y minus 3. And so that will be the final answer in this particular case.